All right. Hello, everyone. We are live to talk about data privacy for LLM applications. Thank you guys for joining. Thank you to Chester and Max for being here. Minor logistics before we jump into it. This is being recorded, so it will be available after the link, and then we'll also put it up on YouTube later today or tomorrow. If you have questions, we want this to be super interactive. This is an area where I think everyone has a lot of questions, myself included. So if you have questions, please drop them in the little Q&A box on the right. So right now, by default, you're probably in the chat. That's what you'll see on the right. If you look beneath the little chat bubble, there's a box with a question mark. You can put questions in there. You can upvote questions that you like, and we'll go through those at the end and answer any of those. Before we jump into the presentations, we can do maybe some quick introductions all around. So my name's Harrison, CEO, co-founder of LangChain. And Max, do you want to do a quick introduction of yourself?
Sure. Hi, everyone. My name is Max. I work as data scientist at DeepsenseAI, where we develop solutions of all kinds, so related basically to artificial intelligence. And we've been working with LangChain and contributing for a while now, and we have been active in various areas, including privacy, hence my presence here. So nice to meet you all, and yeah, that's it. So Chester, now your turn.
Yeah, good to meet you all. I'm Chester. I am one of the co-founders of Opaque Systems. At Opaque, we are building the confidential computing platform for collaborative analytics and AI. So what that basically means is we're building kind of some data privacy solutions to enable secure analytics and AI.
Awesome. All right, let's jump right into it. Max, do you want to take it away?
Yep. So let me share my screen. All right, and you should be able to see that, so I'll start. So today I will tell you a little about my contribution to LangChain, but before, let's start with a short intro. So, LangChain phenomenon is evident, so it is proven by all these popularity charts. So we got something from star history about stars on GitHub, so obviously kudos to the developers, and people want to build application on top of LLMs, and LangChain, well, because of all these tools, chains, integrations, is a good place to start. With all these integrations, users can create a knowledge base based on multiple sources of information. So they can create a system, for example, for question answering, right, based on some number of documents. And, other system can be content creation. So based on the content previously created, we can create a new content, for example, for an article or whatever. And this is especially important for large companies where data comes in from many sources, and it's hard to temper it, right? So it's one big chaos and mess, and conquer it, and the power and money is yours. So like in the Lord of the Rings, one system to rule them all. So a lot of people and a lot of companies are experimenting with creating applications based on LLMs and LLM APIs, right? So APIs. Putting their private data as context to the model. So after all, big companies care about data security and privacy, right? So our data is, at least should be safe, right? My theory, my small theory, is that it is not always the case. And I got some examples right here. I didn't have to look far because all these leaks took place in 2023. And even OpenAI hasn't been immune from leaks either. So in March this year, users with ChatGPT Plus could see, could browse through other users' conversations, on the chat website, and they could also see some private personal payment information, something like that. So, the topic is hot, and there is plenty of controversy. We all probably remember the situation in Italy, where GPT was temporarily banned from the country. And an interesting fact is that my own country, so Polish people, are also questioning it, like questioning OpenAI ability to comply with European standards about privacy. So one complaint was filed with the Polish Data Protection Authority. So four questions arise, right? So what kind of data do we want to protect? what do we protect our data from, what can we do to protect our data, and how can we do it. So I'll answer first 3 questions, and then we'll go to the 4th one, where I will show you my functionality, so my contribution to LangChain. So what kind of data do we want to protect? We got something called personally identifiable information, PII, and it refers to any information that can be used to identify, contact, or locate an individual. So we have 2 categories of PII. First of all, we got linked information, which is more direct one. So it can be any information that will enable us to identify a person based on that particular information. So, for example, email, phone number, social security number, passport number, etc. The second category is more indirect and more tricky, so it's linkable information. So let's imagine we have one information that is not connected to one particular person, but a group. So a connection of some information will allow us to identify one person. So maybe we have a man named John. So there's plenty of Johns in the world, but when we are talking about John, age 23, and he's working as a data scientist at Google. So we can imagine that there is only one John, age 23, working at Google. So that is also PII. So we need to take care of that. Another and even more trickier example is this. So he is a young adult working with AI models in a company that owns the largest search engine. He likes cigars and doggies. So I guess a lot of people like doggies, right? Maybe some of you like cigars, but maybe there's only one person, there's only one man in Google, largest search engine, pretty obvious, that likes cigars and doggies both. And we know that for certainty. That is still PII, so we need to take care of that. So, as I said, the first one, very easy to identify and take care of. The linkable information, more tricky. The first sentence is okay. I mean, we can identify the name, we can identify the age and replace it or whatever. So it's okay. The third one is edge case. So it's extremely difficult to detect such information or similar information. So the conclusion is no matter how hard we try, there can always be an edge case. So keep that in mind. So what do we protect our data from? We can see a snippet from OpenAI privacy policy right here. So it is all about training the models. So they are using ChatGPT chats and DALL-E images for individuals to train the model. And it can be important because we know from some papers that LLMs can memorize training data. So it's not that neural networks are looking for patterns, but they can still memorize it. So in paper from 2020, I know it's far away in our rapidly growing field. It's like a lot years, so 3 years from that point. And we got much better models, much better alignment for the models. But still, GPT-2 was able to memorize some private information, so we need to be careful. For example, we can have a prompt injection or whatever. So we need to take it into consideration. But I know most of us, working with LangChain are using API. So in API or ChatGPT Enterprise, it is not the case. So they are not using our data to train their models, but the data may be leaked from external databases. So even if we use that API, our data is stored for 30 days. So in 30 days, a lot of things can happen, right? So as I have shown before, some examples of some companies and data breaches. So we need to take that into consideration. Our data is generally safe, but we need to take care of that. So what can we do to protect our data for sure? Because maybe some of us don't want to use external APIs or want to protect our data from external APIs for some reason. So first option is to host our own LLM. This is, of course, possible. We can have our own instance of the model on premise. We got plenty of options. For example, Llama 2 or Falcon with different options in case of a size. And there are two problems. First of all, these models are still much worse than GPT-4. GPT-4 is superior right now, and other models aren't even close right now. We'll see later. And the second thing is the cost. So, big tech companies can afford inference or just one or many instances of these models. But small companies, sometimes it's difficult to spend a couple $1,000s on a model. So the second option is, which we'll discuss in detail today, is anonymization, or rather pseudonymization of data. So before uploading the data to the model, so feeding the model with this data, we are anonymizing it. So just replacing the private value with some kind of other value. Right, so in my work, I relied entirely on an open source library called Presidio from Microsoft. So I chose it because of its robust code. I mean, it's robust and it has high customizability. So the authors created a good library, and I will show you the example. So their system is all about these two aspects. So first of all, we got text input. So my name is Eric, and we got a PII analyzer that will recognize the PII. Okay, so we got some built-in patterns. So for example, regex patterns like phone number, let's say. We got named entity recognition models that can identify, for example, a person name or location or organization, whatever. Everything is based on the context search. We can also add our custom recognizers, so custom patterns or custom models. Then when we have it detected, we are using anonymizer part to replace these values somehow. So we can replace it with some value like here, my name is person in parentheses, so a marker, or we can hash it, whatever. Yeah, so that is Presidio, and now it's time for my contribution. So I implemented the integration to Presidio in LangChain and extended it with additional functionality. So this is how my work looks like. It's very simple. I mean, the easy example is very simple. You can customize it if you want, and of course everything is free, open source, and you can anonymize the texts locally. Yeah, so this is the version of anonymization without the ability to restore original entities. If we want to pseudonymize data, so be able to restore the original values later, we are using Presidio Reversible Anonymizer. So I know that naming can be confusing. I will for sure work on that, but the idea is that I will anonymize something, feed it to the data to the model, and then we can de-anonymize it. Okay, so the output. Now let's go through a simple and graphical overview of what a question answering system could look like with anonymization process. First of all, we got simple prompt. So, answer the question based only on the following context. So context and question, right? Is usual prompt. Then we got context variable. It is like some information about stolen wallet. It has name, date, credit card number, and also like Polish ID card number. Then we have question, what was in the stolen wallet. We can anonymize this data using our anonymizer. Then we have these markers. We can feed it to the LLM. We can restore the output. So we got, answer wallet had credit card with number credit card and ID with number ID. And then at the end, we can de-anonymize it. So no private data will go inside the model, the external API. And now some selected features of this solution. So only selected fields to be anonymized. So we can select, using parameter analyzed fields, we can select the PII that we want to anonymize, and other will be skipped, okay? Instance anonymization. So let's see right here. We got two dates, October 19th and October 20th. So we want to treat them as separate instances, okay? So we want to have the date and date 2 in the result, okay? So that's the first thing. Another thing is that if one entity will be repeated twice or more, for example, here my name and surname, Max Perlin, it is repeated twice, so we want it to be one instance. So I'm mentioning that because it is something that is not yet in Microsoft Presidio. because there are some optimization problems, but I found it important to implement in LangChain, so there we go. We got support for custom entities, recognizers. So we can see that we got this Polish ID card here, and it is not by default in Presidio. So if we want to add it, we can just use simple regex, and that's basically it. So we will have this Polish ID recognized. Then synthetic data plus new operators. Operators are tools to replace these values with something. Okay, we saw these markers, and they are okay, but we can imagine, we need to focus on how the models are trained. So usually the training is all about next sentence or next token prediction. This means that the model will provide new tokens based on the previous tokens. So if the previous tokens will be not natural, I would say, so for example, have this marker, this person in parentheses, then the word or token probability can shift, can change. So it can make our results worse. I don't think it's the case for GPT-4, but maybe for smaller models, it can be the case. So it's good to replace it with synthetic values. Okay, so right here, you got some examples of that. And at the end, we got support for multiple languages. So, pretty straightforward. We can have text in multiple languages and anonymize or pseudonymize them as we want. Right, and now let's move to the demo app. So we'll build a question answering app with reversible anonymization, and I will show you an iterative approach to improving anonymization. Everything that I will show you today is already on documentation. So if you're interested, then you can take a look right here. But I will show you that in the Colab notebook. So as you can see here, we are installing necessary packages, and we got a text. The text is all about police testimony. Fortunately, I've never been in police station, so I have no idea how these testimonies look like. But hopefully it's something like that. Okay, the important thing is that we got some PAI right here, like a lot of them. So we want to anonymize them, right? Okay, so we are creating documents. We are using this function to color the PII, so you'll see that in a minute. And here we are selecting the analyzed fields that we want to analyze. So there is like a full list of fields that are analyzed by default, but we want only this, US oriented, okay? And right here, we are initializing Presidio reversible anonymizer with at default faker operators equals false, which means that we will not use synthetic data. We will just use, these markers. So right here, you can see all these markers. We are anonymizing the content of the file, and we got all of this right here. And we can see the mapping right there. You remember that we got a mapping to restore the previous values. So we can see different categories, and we can see different entities. So we got credit card, daytime, email address, and the second one, etc., etc. So I see that two problems here. So first of all, when we'll see a date time, then look, we have date time, date, and date time, time, right? So it's not very, very smart to have both of them as the same entity type. So we want to create time entity for that. And the second thing is that right here, I got Polish ID number, which is not by default in Presidio. I told you that before. So we want to create two recognizers to recognize these things. So right here, we are using Presidio analyzer for pattern creation. We got some simple regex. I don't want to go into detail, but we have a regex. We are adding it to the recognizer. So we got pattern recognizer from Presidio, and we can add this recognizer to our anonymizer. Now, what is important, we need to reset mapping, because you remember previously that we had it right here stored, so it is already saved. So it's good to remove just this entity or all of these entities. So it's easier for me to reset everything and to anonymize it once again. And look, we got Polish ID and we got time, so everything is there. And we got all of these mapping entries. Now let's change it to the synthetic data. So we are using at default faker operators to true, or we can just leave it empty for now because it's by default true. We are using Faker, so we need to set the Faker seed. I mean, we don't need to. We shouldn't do it in production, so the data will be random. And we are adding recognizers and anonymizing the text once again, and you can see all of it is replaced. So we got some random names. By the way, one thing that I want to mention is that in this text there is my Polish name. I mean, I'm one of the 5 people that have this surname, so it's not like in the huge database. So only my family has this surname. So you can see that based on the context, or maybe this uppercase, it's recognized me as person. That's pretty cool. So yeah, that's why I left here my name. But we don't have this values for it, so we don't have operators. We need to create some operators. So we are using Faker library, which will allow us to generate some synthetic values. So for example, here we are using it to create something with like 3 letters and 6 digits right here. Okay, so that's how the example will look like, and that's how it is in case of Polish ID. Here we got fake time, so we got once again, using Faker. We are just adding new operators to our anonymizer, and now we can see we are obviously resetting mapping, and we can see that it is already there. So that's the thing I was mentioning before, that we have a high customizability, so we can add as many things as we want and improve it, and raising the recall of our system. Also Vula. Now the last thing is to put it all together into one system, Q&A system. So we got once again Presidio anonymizer with ability to reverse it. We are adding recognizers operators. Then we are loading the data. So we got documents array, in this case just one document. Then we are anonymizing the data before indexing, because we are using OpenAI embeddings. So at this point, we don't want any data to go outside, right? So we are anonymizing it at this point. We are splitting the documents as usual, and we are storing them in FAI's database. And the last part is to create the anonymizer chain. So we got a template, like a usual template. So answer the question based only on the following context. We got model, so chat OpenAI, and here we got some data manipulation. So we got a question, obviously, which will be provided by the user, and we got anonymized question, which will just use anonymizer to anonymize the question. The whole chain looks like that. So we are manipulating this input, then we are taking the context from anonymized question, and we are passing it to the prompt and then to the model, and we got string output parser at the end. So when we'll ask the question, then we have the information. So where did the theft of the wallet occur, at what time, and who was it stolen from? So you see that we got some information, right? And now the only thing we need to add is the anonymize method at the end, and we can ask the same question, and you see that the data is restored to the original. So I got my name here, the proper hour, and also this location right here. We can ask other questions, so for example, of the content of the wallet in detail. So we got something right here. Everything is de-anonymized. We got something here. So whose phone number is it? We got this original phone. Although you need to remember that we are anonymizing this question, so it is anonymized before putting it to the model. So no data will go to the model in our case. So that's it. If you would like to use local embeddings, or for some reason, if you would like to store original data in your vector database, because why not, then you can use local embeddings, and the chain will look a bit different this time, but I will not go into details. You can check it out right here in the documentation. Right, so that's it from me, and thanks, guys. Questions later, right? Right now.
Yeah, I mean, I have 2 quick ones, not to take up too much time, but one of them is how often do you find yourself writing kind of like custom anonymizers and things to cover like custom, regexes or whatever? Like, is that a common thing you do? Like, do you always find yourself having to do that, or is that like more the exception than the rule?
Well, I would say it is very important because it's very data specific. Like all data sources are different, right? So as I said, as a Polish guy, I have a lot of these things repeated. So for example, Polish ID is one thing, but also Polish phone number is different. Okay, so if somebody will write a Polish phone number, then it will not be recognized. It is much easier for data from America because all of that is present in Presidio by default, so it's easier that way. I would say it's not like you should use it without any thinking of that. So you should first check what data is anonymized and check the recall of that. So how many fields were recognized manually, probably, and then add it and iteratively repeat this process until our system will be good. And it's not like you will have 100% sure, right? We cannot be sure. So it's something that we need to improve.
Well, and then I'm also curious, like, and I think you like are there cases that you found where you wouldn't want to do this? Like if I'm building a chain and I want to like extract like the length of people's names, right? Like if I replace their names with a different name, that then it's going to completely fail. That's a bit of like a toy example. Are there any real world examples where you've found that you just don't want to do this?
Yeah, sure. I mean, one thing that I have in mind is that well, it's very language specific because in Polish language you got something called declination. I don't know if that's the name in English, but if I am saying I am Max, nazywam się Max, so my name is Max, but I'm going to Max, so the translation is idę do Maxa, so it's not the same word. So you can see that this exact match will fail right here. So that's one thing. Any other examples? Well, I don't have anything in mind, like in a production case. In some, sometimes you just using your on-premise Llama or whatever, like other different model. Then in that case, you would not like to use it because there's no need for that, right?
Awesome. All right. And I think you got one question about the collab. Like, is that collab file available?
Yep, you can open it right here from the documentation. I have I think 2 changes in that notebook, so I will push them. I mean, I will do a merge request today or tomorrow, so we'll have the full thing available.
Awesome. And maybe you can share a link to that in the chat right now.
Okay, sure.
Cool. All right, Chester, do you wanna take over now?
Yeah, sounds good. Second. Oh, Max, we'll have to start. Okay, there we go. Cool. Yeah. So today we'll be talking about something very similar to kind of what Max went over towards privacy preserving generative AI. So a little bit more background on myself. Our team that kind of came out and founded Opaque, we were doing research for a number of years in privacy enhancing technologies in the RISE Lab at Berkeley. So today we'll be talking about a little bit about generative AI, of course, but also confidential computing. So we'll give a quick intro on that, and then we'll also talk a little bit more about how we can apply confidential computing to generative AI to plug a lot of the privacy gaps that we've been kind of hearing from a number of different folks. So yeah, this intro is very similar to Max's. We've kind of been seeing a number of growing privacy concerns. So I think the first kind of really large privacy kind of leak that we saw was that Samsung employees shared source code with ChatGPT and also used it to summarize meeting notes, which Samsung deemed non-compliant with their internal policies because the employees were leaking proprietary information to a third-party provider. Similarly, in Italy, and I think Max already mentioned this as well, but Italy banned ChatGPT for a while, claiming that it unlawfully collected, used, and retained users' data. And even worse, right? Conversations from one user were actually visible to a different user. And in general, we've seen a number of different companies in a number of different sectors have concerns, anywhere from Apple to the big banks, JP Morgan and Citi, to even like a telecom provider like Verizon. So now that we've established that companies big and small are concerned about the privacy of LLMs, let's further dive into what those risks are. So I'm sure that everybody here is kind of familiar with the retrieval augmented generation architecture, so we won't go too much into that. What we will do is kind of take a look at which parts of this architecture are run on a third-party platform. And later we'll go into why running on a third-party platform may not be the most secure thing. So as we've kind of seen, right, as the space has matured, vector databases have become a very popular SaaS offering with companies like Pinecone, Weavy, and Chroma. And what these companies are doing is they are mostly hosting these databases in their own environment, meaning that you as an application developer, when you insert the documents into the database, the providers usually get to see the documents that you insert. And additionally, because the LLM itself is often run on a third-party premise. So here, think OpenAI, think Anthropic, or think Google. When you are making an external API call to these providers, you are also sending your prompts or your inputs to these providers themselves. So why do we actually care about the LLM or the vector database running on a third-party premise? Well, in particular here, in model development, if you are developing the model on sensitive data, the sensitive data is being pushed outside the user environment. And similarly with inference, if you are performing inference on sensitive data, so think PII, as Max has previously gone over, or think other types of data that a company itself may deem sensitive, then model inference may also happen outside the user environment. So diving deeper into model development using proprietary data. So to help frame this more concretely, right, let's take the example of an application that will serve as a company brain. So here, imagine that you're trying to create an LLM that can answer any question about anything happening within a company from any employee. So for example, let's say I want to ask about yesterday's action items from the meeting at 2 p.m. Or I want to ask a recruiter or the hiring manager what the recruiting pipeline looks like. So the company brain here is essentially a model that is continuously trained or fine-tuned on new company data, whether that be internal documents or conversations between employees. And as more conversations happen and as more documents are created, then the model needs to be iteratively and continuously developed. And while overall this application in this brain will be super useful for the company as a whole to prevent something like tribal knowledge, these documents or the conversations used to train the model may contain confidential data that is required to build an effective brain. So the company may not want to share this data outside its premises. And this is basically what happened with Samsung. So next, let's take a look at model inference. So similarly here, the prompts or the inputs, so for example, the user query may contain confidential data, but inference also happens on the third-party provider's platform, meaning that the third-party provider can see the entire contents of the prompt. So extending the kind of company brain example here, let's say that an employee in finance may want to ask questions about the balance sheet or the profit and loss statement, which may not be public. But since the inference happens on the third-party provider's platform, the provider may actually be able to see some of the sensitive financial numbers that are included in the employee's prompt. And in particular here with model inference, we've actually heard particular concerns about the provider's data usage, collection, and retention policies. So in other words, what the provider does with the data used to query the model. And I think Max, earlier mentioned something about OpenAI, storing the data for about 30 days. And from what we've seen, we've done a bit of research on this. They're actually one of the better companies. So a company like Google, I think they have an option to go up to either 120 or even an entire year, 120 days or an entire year. So one solution to kind of the aforementioned issues is a customer deployment of the model. So here, the customer could either fine-tune or host the model on-prem. And what this basically means is that the model will run in the customer environment. And as a result of that, the model is not hosted in the third-party environment. However, this would require that the foundation model be shared with the customer. But obviously, companies like OpenAI may not want to do this because they have invested a significant amount of capital in developing the model to be as good as it is. So next, let's kind of switch gears a little bit and talk a little bit about confidential computing. And hopefully this will give enough of a background to those who are not familiar with the technology to understand how confidential computing can plug a lot of the gaps that we have previously outlined. So first, let's kind of discuss what problem confidential computing is solving. So today, data protection can be thought of in three parts. The first part is data being protected at rest. So in other words, when it's in storage. And secondly, when it's in transit. So for example, when it's sent over the network. And these two problems, or these two parts, have long been solved problems. For example, databases have for a while now stored your data encrypted, and we have network communication being encrypted for a long time now. So think HTTPS or TLS. The last part of data protection is the protection of data in use. And unlike the first two, protection of data in use is still not prevalent. So this means that while data is being processed, so for example, when you're doing LLM training or when you're doing inference, the data used during that processing is unencrypted and is fully visible in the environment. So confidential computing is a solution for protecting data in use via the use of something called hardware-based trusted execution environments. So for key takeaways here, it's important to know that TEEs guarantee the confidentiality and the integrity of data, meaning that nobody can see or tamper with the data, and they also guarantee the integrity of code, meaning that nobody can tamper with the code that is running inside of a TEE. So for a little bit more background on a TEE, essentially they provide an encrypted region of memory that the CPU or the GPU can use. So what we've depicted here is a graphic representing a specific implementation of a TEE called Intel SGX. And the key to TEEs in general is that they allow you to significantly reduce the size of your trusted computing base. So with Intel SGX, the new trusted computing base is depicted here in blue. And previously, without a TEE, you would have to trust all the components in red not to tamper with the memory because the data was just sitting in memory unencrypted. So what this means is that somebody with root access to the machine, for example, could just dump the memory while it was being processed. And this would allow them to gain access to whatever data was being operated on. But now that the memory is encrypted via a TEE and only accessible to the components in blue, none of the components outlined here in red have the ability to tamper with or any visibility into the data that is in memory. Another very important feature of confidential computing is remote attestation. So when we say TEEs are testable, we basically mean that you can verify that the TEE hardware is genuine hardware. What this means is that it was indeed, the hardware was indeed manufactured by a manufacturer of a TEE. So think Intel, think AMD, and also that the code running inside the TEE is what you expect. So here we can actually perform some cryptography to verify that the code is the code that you think it is inside of the TEE. So putting this all together, right, why do we even care about confidential computing and what does it enable? Well, first, with attestation, you can trust that a provider has actually launched a TEE and that the TEE is running code that you expect. And additionally, you can trust that the provider cannot tamper with the code that is running, and that the provider cannot see or tamper with the data that is being processed within the TEE. Okay, cool. So how does this apply to generative AI, and how does this solve some of the problems that we outlined earlier? So first, let's take a look at the confidential retrieval use case. As we mentioned earlier, right, it's usually insufficient to have data encrypted only at rest because the vector database provider may be able to see the documents while they're being inserted or while there is some query being executed on the data within the database. So what we can do is we can actually make this retrieval process more private by running the vector database in a confidential computing environment. And running the vector database in a TEE means that any query execution can operate on confidential data, and most importantly, that the database provider cannot see any data when it is retrieved. So next, let's take a look at how confidential computing can help preserve privacy during model development. So again, in this case, we want to train or fine-tune a model that is hosted by an external or third-party model provider. But imagine here that the data is proprietary, so we do not want the provider to see it. The solution here is to use confidential computing to ensure that the provider does not see the data used to train or fine-tune the model. So what the workflow will look like here is that the provider can launch a TEE, which enables the data owner to verify that the provider is running the code that they expect, and that the provider cannot see or tamper with their data. the data owner can then trust that any data it shares for training or for fine-tuning with the model provider cannot actually be seen by the provider, but that the provider is actually using that data to train or fine-tune the model. And similarly, we can use confidential computing to protect both parties and the data during inference. So again here, the model provider can serve the model in a TEE, meaning that any prompts or queries that the user submits are not viewable by the provider. And because the prompts or queries are not viewable by the provider, all concerns around data collection, around data usage, and around data retention go away, because the provider cannot even collect the data because it's not visible to the provider. So much of the kind of solutions that I mentioned in the last couple of minutes around confidential computing require a lot of computing power, and in particular require GPU for performance. GPU TEEs are not yet widely accessible, even though NVIDIA is kind of working on that, and they're supposed to be out by the end of the year. So a stepping stone towards private LLMs is prompt sanitization, and this is kind of very similar to what Max mentioned in his talk with what Presidio does. So here you can imagine that prompt sanitization is essentially a privacy layer that sits between an application and the LLM that removes sensitive information in the prompt before it reaches the LLM, and then replaces the sensitive information in the LLM's response. The key result to this is that the LLM no longer sees the sensitive information, and this solves the same core issue of data retention and data collection. And most importantly here, the sanitization and the desanitization will happen in a confidential computing environment, meaning that whoever is hosting the prompt sanitization layer also cannot see the sensitive information. So at Opaque, we have built a product called Opaque Prompts that does exactly this. And to kind of give a more visual view of what Opaque Prompts does, we've created this side-by-side view. So here we have kind of two GIFs. On the left, let's first talk about what happens without Opaque Prompts. So in a typical application architecture, so here the LLM application may collect some context from a vector database that may contain some sensitive information. So in this example, the user prompt here contains the name Sherlock Holmes, as well as Sherlock Holmes' address, 221B Baker Street in London. The application then sends the user prompt to the LLM. So in this case, the LLM is able to see Sherlock Holmes' name and address. And like we've all seen, the LLM will generate a response and to the user query and then return the response to the application. So next, let's take a look at what will happen with opaque prompts in the picture. So as before, the LLM application constructs the prompt from the context in the user query. But with opaque prompts in the picture now, the application will securely share the constructed prompt to opaque prompts, which again is running in a confidential computing environment. Now, opaque prompts will sanitize all the sensitive information out of the prompt. So similar to what Max mentioned with Presidio, Sherlock Holmes' name will be replaced with a placeholder, and Sherlock Holmes' address will also be replaced with a placeholder. The sanitized prompt then goes to the LLM, which is now unable to see any sensitive information. But because the LLM does not rely on the personal information here to generate a response, the LLM will still be able to generate a logical response, which in this case may contain the placeholders. The LLM then sends back the sanitized response to opaque prompts, which replaces the placeholders with the original sensitive data and returns the response to the application. So importantly here, it's important to note that the user experience from the application side is exactly the same as it would be without opaque prompts sitting in the middle. So opaque prompt enables this kind of transparent privacy preservation of the user prompt. So that's the end of the deck. So let's quickly go into demo to see opaque prompts in action. Let me share to a different tab. And so here we have the opaque prompt page, and let's just sign in. So we have built a chat application to demo the core functionality of opaque prompts. This chat application is actually built with our LangChain integration with opaque prompts, which we can share out in a bit. While the chat application here is what we will demo, the main consumption mechanism of Opaque prompts is actually via an API. So if you register to our waitlist and get access, you'll be able to get an API key that will enable you to integrate Opaque prompts into your LLM applications. Okay, so getting back to the demo here, let's say we want to ask some questions about this text snippet. So this text snippet is a snippet of text from a CIA operation that happened in about the 1970s, and that involved recovering a sunken Soviet ship from the middle of the Pacific Ocean. Let's say we want to ask, so in this case we have ChatGPT in the background. Let's say we want to ask, a question about the snippet. So we want to ask what was recovered from the submarine. So if you ignore all this middle stuff, you can see that the chatbot answered correctly. So we asked what was recovered from the submarine, and the chatbot correctly answers. The contents of the recovered submarine included the bodies of 6 Soviet submariners. And we can see that it is indeed the correct answer here. And this is pretty cool, right? It's just a normal chatbot application. But if we look closer in the background, we can see that the prompt that was sent to the LLM after Opaque prompts processed it actually removes all the sensitive information. So in particular here, if we're able to compare, we can see that the location Long Beach has been removed, the name of the ship has been removed, the date that the ship arrived over the recovery site has been removed, and other personal information, for example, the name of the CIA director, as well as the name of the, in this case, the Russian president was also removed. So this text is exactly what the LLM sees. And importantly, again, the LLM does not see any of the PII. Even though the LLM is not able to see the PII, it is still able to successfully respond to the correct answer because it does not need the PII to do so. So next, let's ask it another question. Let's ask it, when did the ship sail over or arrive over the recovery site? So again, the LLM is able to respond correctly, and we see that, in fact, the LLM does not know the PII details, so the underlying PII on which it responds, but with the chatbot application and using Opaque prompts, we're able to show the user all of the correct information. So we're able to replace person 3 with Glomar and date time 3 with July 4th, 1974. So yeah, that's a bit of a demo of what Opaque prompts can do. And yeah, that's the end of the talk. Thank you so much for listening.
Awesome. All right, so okay, I see some questions coming in, so we'll spend the next 10 minutes kind of taking a bunch of these questions. So please, if you can, drop them in the QA box on the right, although I also see some in the chat. And so yeah, maybe I'll take the 2 in the chat first, but then again, let's try to go to the QA box in the right. First question is basically like, what guarantees can you provide that sensitive data will be masked? And so I don't know, maybe both of you can kind of like take this from your end, both on what you've seen. Maybe Chester, you can start because you're kind of offering more of a service for this, right? So what guarantees do you guys have?
Yeah, sure. So we use some machine learning in the background to kind of provide these guarantees. Of course, this will not be 100% perfect, to be completely frank. We are always kind of working on improving the accuracy of the model. Because we know that it's critically important, right, that the sensitive data will be masked. But it's, because we're using machine learning, it's very difficult to kind of get 100% accuracy. And as a result of that, we've kind of seen that, it's important to do some kind of trial runs at the beginning to make sure that we can, tune the model specifically to each individual use case.
Cool. Yeah, Max, do you have anything to add for this around Presidio?
Yeah, I mean, I read some paper, like I think it has like 2 years or something like that. So they measured the recall of Presidio, just this default operators and recognizers. And I remember it was something about 85%. So it's from one side, it's a lot. From other side, it's still 15% of non-protected data. So I guess, as I said, it depends on the data. So it's very important to not leave it like that. So as with default recognizers, but to add your own and to check it. So it should be checked by human before we can put it in the production. And still, it's like when we don't have 100% probability of all this PII being masked, then still we need a consent from user that we need to we are taking your data. There is some threshold that we provide you that the data will be protected, but still, I mean, we need a consent, or it will not be it will be against some policies.
I'll also add here that if you do want 100% accuracy, that the sensitive data cannot be seen, I think confidential computing is actually a great solution here, right? Because anything that you put into the TEE is guaranteed to be not visible to whoever is running the TEE application.
Cool. So I see one question in the chat and one question in the QA that are basically the same, and it's like, do we have any way of distinguishing if PII is relevant to the query? For example, let's say George Washington was mentioned in the query, and it would be better to send that PII directly. Or I think the other example in the chat is if I ask for things to do close to this town, like that town is a place or something, if that's considered. But like, yeah, is there any distinction between PII that's relevant and not relevant, and how do you think about that? How do people generally approach this? And I know I asked you a little bit about this, Max, earlier, but be curious for Chester's take on it, and then anything else that you'd have to add.
Yeah, so we've actually heard this a lot from a number of different conversations that we've had. So as an example, right, I think we spoke to a manufacturing company that mentioned that there's some manufacturing data or manufacturing terms that are very specific to that field that you would normally not deem as sensitive or as PII, but we'll need some way to kind of distinguish those keywords in the specific context and for specific customers, as opposed to in the kind of generalizable case. So our answer to that, right, is that first, I think the key feature is that we need to provide some kind of configurable way. So I think, Max, from your Presidio kind of a custom thing, you also offer kind of a feature to enable this, but we need to provide some kind of customizable mechanism to enable users to really define what is sensitive in their case. And then on the technical side, in the background, right, I think the kind of key there is we'll need to almost use like an LLM and fine tune the LLM such that it can identify specific terms in specific categories.
Right. So from my side, I mentioned named entity recognition models before. So like the basic implementation in Presidio is all about spacey models. So they are like really small models, and it's all about recognizing all these named entities. And if we would like to, we can, for example, train a transformer based on our data, and mark in our data set, we can mark George Washington as not PII, and for example, Max Oberlin as PII. And maybe that way, based on your data, the model can be trained to recognize the good entities. And another thing I think it's important is that when we have a question about George Washington, and we have a system, QA system, that needs to answer the question based on the context, then it should be based on the context. So we don't want the system to answer the general knowledge information. So it's not like a quiz of general knowledge. It's a question answering about our documents. So I guess if it will be anonymized and then restored, then everything should work perfectly. So if we have George Washington in our text, then it should work smoothly.
Let me find. All right, so this is a bit of a longer question, but basically it seems like there's two different threat vectors that were attacked here. One, preventing LLMs from outputting sensitive data, which might be latent in kind of like the training via scrubbing PI from queries outputs through pre and post processing. And then the other would be preventing kind of like third-party model providers from learning about customer sensitive data through TEs. Are there other, like, just in general, if we think about the general problem of kind of like data privacy for LLM applications, are there other like issues or threat models that we didn't spend a lot of time talking about that you think are interesting or relevant to highlight to folks? Specifically like around data privacy. or are the topics that we covered today, this is what you spend 99.9% of your time talking with customers about and addressing their data privacy concerns?
Yeah. Sorry. Okay. Yeah. This is generally kind of what we've seen. We've kind of seen the main kind of threat model be that they do not necessarily trust the provider, whether that be the LLM provider or like the vector database provider or something else, or even the cloud. So interestingly, right, we've actually had some conversations with some of the big banks, and what they shared is that not only do they want to run the LLMs on-prem or in their own trusted environment, but they also want to run LLMs on-prem in a confidential computing environment. So they have kind of that stringent privacy constraints that they do not even trust their own kind of admins or their own employees to, I guess, not peek at the data that is being processed, even in their own data centers.
I don't think I have anything else to add. I mean, I was mentioning the prompt injection, but I guess it's part of this question. So it's all about, you know, LLM memorizing and stuff.
Cool.
Oh, actually, I have something else to add, Harrison, if that's
cool. Yeah, I mean, we'll maybe use this as final comments as well for anything that people want to add before.
Yeah, sure. So this is, I think, a little bit more of an academic perspective, right? But I can imagine that in the future, right, if you want like a very, very low latency or very, very kind of real-time use case, that you may actually want to push the model into the customer environment itself, such that the kind of network communication is much shorter. What that means, I might have gone over this a little bit in my talk, is that we'll actually need the model provider to share the model with the customer. And because the model itself is very, very private, right? The model provider has invested a lot of capital into developing the model. They absolutely do not want the customer to see the model weights. So you can imagine here that if you want to share the model, it's actually the customer that is considered the threat in the threat model case. And the customer has to not be allowed cryptographically to see the model that is running in their environment.
All right, well, we're out of time, so I wanted to thank you both again for joining, and thank you everyone for tuning in. Again, we'll post a recording of this shortly. I think there was a lot of good insights here. I think this is a thorny subject, but hopefully now we have some good material to go off of. So thank you guys for joining. Really appreciate it.
Yeah, thanks.
Thanks all. Yeah. Bye-bye.